Hello, everyone. Welcome back to Creation Myths. We're live again for the second week in a row, and I have kind of a lighter one, kind of a fun one tonight, something we haven't done in a while. As always, chat, welcome. It's a pleasure to see all of you here. I love seeing all the familiar names. Uh, Thank you all for being here. Please let me know if the audio and the video looks and sounds okay. Everything looks okay on my end, but just if there's any issues, let me know and I can fix things as we go. So what are we doing here tonight? Now, actually, before we get into tonight's topic, let me just say that unlike last week when it was extremely spur of the moment and really busy with work and didn't have time to kind of plan anything, tonight I get to plan out my schedule a little bit for this week, for next week. I've just been able to lay some things out a little bit. So I have next week's video ready to go. And for people in the future, it is, as I say this right now, it is September 17th, 2025. So we're live tonight. And then I've got a recorded video available for members that will premiere next Wednesday, the 24th at 9 p.m. So I'm really excited for that one. I think it came out really nicely. And that actually came from a viewer. I asked for suggestions of what I should cover, and one of the suggestions was a long story short video. So I found a particularly good / bad one, and that's what we're going to do next week. And I'm really excited about that. So let's get into tonight's video, because tonight we are going to do something that I haven't done in a while, and I think it's overdue. It's dunking on standing for truth. It's been too long, so that's what we're going to do right now, because he's been putting out a whole bunch of articles on various, evolutionary claims and then the creationist counter arguments. And he put one out in particular that is just basically, well, I'll show you, and I'll let Standing for Truth in the introduction explain the purpose and the kind of thinking behind what we're going to talk about tonight. So let me pull this up right here. Here is what we are going to do tonight. And this, by the way, is linked down below. If you want to read the whole thing without my commentary, you can go and read it, and you can download it and have it for yourselves. So this is the ultimate guide to debunking evolution's best evidence. Why common design explains data better than common descent. And I'm going to scroll down to the author's note here, right? Basically saying this isn't an in-depth thing. This article has a different purpose. This article is a cheat sheet, a quick reference guide to use in real-world conversations. Basically, this is something that Donnie, Standing for Truth, put together for his audience to give them responses to the most common evolutionary, evidence, arguments, whatever word you want to use, and have kind of, quick responses at their fingertips. And I want to highlight the purpose behind this, because the big thing that I want everybody to take away from what we're going to go over tonight is twofold. One, we are going to go through these arguments, and there's a bunch. There's like 12 or 13, and we're going to go through most of them. Some of them are outside of my area of expertise. There's like some geology stuff that's just like not my thing. But to the extent I can address these, I will, and many of them are extremely easy to address. But the other purpose, the second purpose I want everyone to take away from this, is that this is designed as a resource for kind of non-expert creationists, right? Amateur creationists who are having the evolution creationism conversation in real life, on YouTube, wherever. And in terms of that, in terms of giving those people something they can use effectively in those conversations, this is terrible. This is absolutely awful. And like I said in the title, this cheat sheet only cheats creationists. It cheats the audience, that it's intended to help, because the arguments in here are so amateurish, they're so shallow, they're so easy to refute and obvious. Anybody with a passing understanding of these issues, anyone that spent a little bit of time having these conversations on the evolution side, knows how to deal with the arguments that we're going to see in here. So this is meant to be like a quick reference guide for refuting evolution. And what it's really doing is setting up Donnie's audience for failure when they have these conversations. Because I guarantee you, most of you in chat right now, you don't need my help addressing any of these arguments. You can all do it yourselves at this point. You don't need me to tell you why these things are wrong. And that's really bad for the creationists here. That's not a good thing. So one last thing before we get into the point by point here is I will just remind everybody that in the description is linked the bingo card, and this is a great one to play bingo with, because we are going to see a bunch of different arguments here, and Donnie is really going to hit the the classics. He's going to play all the classics in this one. So if you want to play along, this is a great opportunity to get in a round of Creationist bingo. And also, if you are doing the Creationist drinking game, make sure you are drinking responsibly. Don't go overboard, because again, we're going to hit a lot of the notes in this one. So let's get into it here. I'm not going to take a whole lot of time with this, right? So let me just show you the first one, and then I'll show you kind of the length and the complexity we're dealing with. It's not very much. And then you'll see that we'll be able to go through this pretty quickly. So here is our first one, homology, right? And the evolutionary claim, shared structures across organisms point to inheritance from common ancestors. Yeah, that's a reasonable characterization of the claim in one sentence. Sure. Yeah, the fact that you have not necessarily just similarity, but you have like specific shared structures across different things shows like that is a confirmed prediction of common ancestry. Yes. Now, some of the claims that we're going to see here are just wrong. Like some of these are going to be egregious straw men. So we'll get to that when we get to it. But this one is fine, right? So right away, we get human engineers designed with homologous patterns, right? You reuse things, whatever, right? He goes right to the car analogy, which we've all seen a million times. Now, a couple problems here right away. The car thing is cars don't reproduce, right? So it's not an analogy for biological systems. You have to explain the patterns of similarity in the context of things that reproduce. And you could show like common ancestry within a family, kind of ancestry within, when I say family, I mean in like a people family, not a biological taxonomy family, but you can mean it that way too. Common ancestry within a species, whatever, right? So you need to account for those dynamics, and those dynamics predict similarity of whether it's genetic patterns or morphological structures, whatever, right? So it is a confirmed prediction. So saying that, well, human designers do this too is not an argument against the evolutionary hypothesis, right? So we go right to common design, not common descent. And you all probably know at this point, when I hear the phrase common design, what is my favorite go-to? What is the best go-to here? You don't have to talk about how cars don't reproduce or anything like that. You can just say nested hierarchical pattern of similarity, directly confirmed prediction of common ancestry, impossible via common design unless you have supernatural tinkering to change the rules along the way, which is unfalsifiable. So you can go with that, but it's not scientific. So that's kind of how we're going to do this. That's our first one. That's it. There's like, I don't know, 10 or 12 of these we're going to go through. It's not going to take very long to go through these because this is the level of sophistication we're going to get in this document. Now, I see a really active chat here, and like I said, I appreciate all of you being here. Let me just see, make sure I didn't miss anything here. I see a lot of people. Hang on, Dan, serious question. Where did that one go? I want to just highlight this. Here you go. Serious question. Have you ever considered building simple notebooks like R, Python notebooks dealing with your argument for testing common ancestry? So I have not personally considered doing that because like other people have. That's what the paper that I've talked about at length does. Other people have built simple models with this. I actually think Zach Hancock, Talk PopGen, has done some stuff along those lines. I think he's mentioned that at least in some comments before. But also, I just don't have time to like sit down and do that stuff. I haven't done any Python since graduate school, and I'm not going to say how long ago that was, but it was long enough ago that it would be too much time for me to spend on it. But people have done that kind of thing, yeah, and it's valuable, and it shows the common ancestry is well supported. Good thinking. So let's go to comment number 2. Oh, perfect. Nested hierarchies. Great. The tree-like classification of organisms supports descent with modification. The wording there is kind of weird because the nested hierarchical pattern of similarity in genomes specifically supports universal common ancestry of cellular life, right? It's kind of a bigger thing than descent with modification, which is how Darwin described evolution by natural selection. So Donnie's response here, nested hierarchies arise naturally in design systems, right? And we're right back to the car analogy. We're right back to engineers reusing components. And then he gets into this second part that I highlighted, I think is useful here, right? Similarly, biological hierarchies reflect design logic. And I think what that is an allusion to, a reference to, is the Winston Ewart dependency graph model, which we are going to talk about on this channel in the near future. I know I've been saying that for a while, but I promise you I'm just about ready to record that video. So here's a little preview about that model, because anytime you have a creationist bring up the dependency graph thing, here's like the quick go-to that you can use to explain it. They're going to bring in that original Winston Ewart paper. And here is the thing in that paper. He doesn't look at sequences when he's making his dependency graphs. He's looking at the presence or absence of gene families. So he says that his dependency graph model does a better job explaining the nested hierarchical pattern than common ancestry, but common ancestry explains the pattern of sequence similarity at the nucleotide level, right? You do sequence alignments and then build your phylogenetic trees based on those alignments. That's not what Ewart did with the dependency graph model. He just mapped the presence or absence of gene families and sought to explain that. He completely ignored the pattern of similarity in the sequences of the genes themselves. Completely ignored it, which makes the whole thing completely irrelevant to the claim that they're making, that it does a better job explaining the nested hierarchical pattern than common ancestry. It's not even comparing the same thing. Okay. So that's number 2, nested hierarchies. Claim number 3, transitional fossils. So now we're going to do morphology stuff. Transitional forms like Tiktaalik, mammal-like reptiles, or Archaeopteryx demonstrate gradual evolution. Pretty much, yeah. They show that species have changed over time. Creation response, the fossil record shows mosaics, not transitions. I have never gotten a satisfactory answer for what the difference is between those two things right here. You'll hear this from Donnie and other people and say, whatever specimen is a mosaic. It's not a transition. What's the distinction there, right? The idea of a mosaic, like Tiktaalik is a great example of this because it has a number of features that are distinctly fish-like, right? It has gills, it has scales, right? It's the limbs have like their flippers, they're for moving in water, right? But then it has a number of other features that are indicative of terrestrial living, like a flat head with eyes on top, and specific bone morphology in the limbs arranged a certain way, right? It had lungs. Now, you could say, oh, that's a mosaic. It's a mosaic of marine and terrestrial morphologies. Yeah, that's the point, because it's a species that represents the transition between those states, right? That's the point. That's why it's a transition, because it has features of both. To call that a mosaic, not a transition, like, I don't even know, I don't even understand the point of like those words. I don't understand what the distinction is there. And again, we go right into a vehicle thing, looking at military amphibious assault vehicles, right? Cars don't evolve, vehicles don't evolve. So there's no inheritance, there's no hereditary relationship between those vehicles, right? So remember, if evolution were true, there should be tens of thousands of unquestionable transitions, not a handful of disputed examples. Please pick up a book, any book on evolution, anything at all. There's so many you could do. I mean, I've got your inner fish right there behind me. I've also got The Rocks Were There. Another great one is Evolution Slam Dunk by R.J. Downard, looking at the reptile mammal transition stuff. These are beautifully documented fossil series where you don't just get like a specimen intermediate where it has some states of one and some states of the other, but you have a series of specimens where it's 100 to 0, 90 10, 80 20, blah, 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 all the way to 90 10 in the other direction, right? So you can look at, whale evolution is a really nice example of this because of the way the ear bones and the ankle bones overlap in the specimen. So you have the more ancestral states where you have the very distinctive ankle bone, and then morphology people, I forget the names of these bones off the top of my head. Don't get mad at me. It's a distinctive ankle bone and a distinctive ear bone. And you have the very distinctive ankle bone, and then at some point in those specimens, they have both the ankle bone and the distinctive ear bone that modern whales have. And then obviously as the limbs transition to fins, the ankle bone goes away, but they keep the ear bone. So you have this very clear progression in the fossil record that I'm sure you could call it a mosaic, in that it has features. Literally, if it has both the ankle bone and the ear bone, it has features of terrestrial mammals and marine mammals. It's a mosaic of those two things. But it's the progression in the fossil record from earlier to more recent that shows the transition series of that particular lineage. And there are tons of examples of this. And every time I bring up stuff like this, I just love that everyone in chat just starts spamming their favorite examples of this. And I'm just going to highlight one because it is such a beautiful example. This is from friend of the channel, Mr. Anderson. It's good to see you, Mr. Anderson. My favorite example of transitional species is microfossils that have transitions so smooth that drilling companies use them to find oil. Yes, it's beautiful. You find these wonderful, smooth transitions, these gradients of transition in the fossil record that are so precise. Once you establish when certain specimens lived, you can actually date other formations by the presence of those specimens. It's super cool. So yeah, this is just a silly point. Like, I don't know what to make of this, that there aren't tens of thousands of examples of this. There literally are. It's night and day. You just either accept it or don't, but it's just reality. Now we're getting into a really fun one. Chromosome 2 fusion. Evolutionary claim. Human chromosome 2 shows evidence of fusion proving ancestry with chimps. Now, first, let's just dispute the proving ancestry line here. It's not proof of ancestry. You don't prove things in science. That's not how science works. But it is strong evidence of common ancestry because it is a directly confirmed prediction. It's a directly confirmed prediction, right? We look at the human genome, we look at the chimp genome, we say, hey, we're missing a couple of their chromosomes. We have one pair fewer than they do. There must have been a fusion. Turns out we can take their chromosomes 12 and 13, smash them together end to end, and you get our chromosome number 2, which they don't have. Perfect. Exactly confirmed prediction, not just like the numbers, but the details of it. And we're not going to take a whole bunch of time here going into all the details of chromosome 2 and how we know that it's a fusion event, and the fact that you have the cryptic centromere and the end-to-end telomere and the synteny, the way the two chromosomes, human chromosome 2 and then the two chimp chromosomes line up in terms of like the sequence and the banding pattern and everything. We don't need to go into all of those details. If you want a ton of those details, I invite you to check out a show I did just a few weeks ago with Mike from Answers in Atheism. He was here. So if you go back a few weeks for that show, you can check that out. And then he recently broadcast that on his channel, so you could watch it there as well. So tons of details on the human chromosome 2 fusion there. So now let's get into this. Even if true, the fusion would have occurred in the human line, not showing relationship to chimps. I think that's just a misunderstanding of how this evidence works. Like, I don't know. Fusion fixation is also problematic. No, it's not. I want to get down here to this part that I highlighted. Creation offers a cleaner solution. Post-flood bottleneck could easily fix such a fusion. So now he's saying this could have happened in the human lineage after creation. Like, this could happen at some point in the history of humanity in the last 6,000 years. And he says signatures resembling fusion sites appear elsewhere in the genome, chromosome 9 with no fusion history. That's wrong. Those sites actually look pretty different from the one in chromosome 2. They don't look the same. And then, by the way, Gutsick Gibbon has gone into a lot of detail on the chromosome 9 thing in her back and forth with, I think it was Jeffrey Tompkins and Rob Carter talking about chromosome 2 fusion. So highly recommend you check that out. And then he finishes it with just perfection. Evidence is at best agnostic. When you hear a creationist say that, what that means is I have no good response, but I can pretend that creation can accommodate this observation as well. That's what that means. When Donnie says it's agnostic, what he means is, well, it sure looks like it happened. I can't really argue that it didn't happen. I don't have a serious argument that it didn't happen. So what we'll go with is that it's not a problem for me if it did happen. But here's the thing. It's evidence for evolution because it is a confirmed prediction of evolutionary theory. Specifically, it is a confirmed prediction of human-chimp common ancestry. That is not the case for creation. Any creationist can accommodate a human chromosome 2 fusion because there is literally nothing that their model can't accommodate, because they can just put miracles in it. They can change the rules of genetics. They can have the created states be whatever they want and then say God made it that way and made it stay a certain way or made it change in a certain way between creation and the present. There is nothing that creationists will accept that their model cannot accommodate. But that's different from it being a confirmed prediction. And this is a confirmed prediction of evolution, which quite explicitly makes it evidence of evolution, and specifically evidence of human-chimp common ancestry. So now let's get down to one of my favorites, endogenous retroviruses, ERVs. Evolutionary claims. Shared ERVs are ancient viral scars inherited from common ancestors. And I would go further and say that shared ERVs are not just like the remnants of ancient viral insertions in the genome. They're also one of the single strongest pieces of evidence for common ancestry because of the pattern of shared endogenous retroviruses across different species. For example, within the primates or between the primates and the rodents, to use a few common examples, right? So the way we know that these are actual viral insertions is through features called target site duplication. So when something like a retrovirus or retrotransposon inserts in the genome, you get what's called a target site duplication, where the insertion site ends up duplicated on either side of the inserted virus. The target site duplication is a directly observable feature of these things because we know of viral insertions that are new. They're not fixed in the entire human population or other species, whatever species you're looking at. Koalas are a good example. So we have some koalas that have the viral insertion and it's got the duplication. And we have other koalas where at that same site in the genome, they don't have the insertion and there's no duplication. It's just one copy of that sequence instead of two with the virus in between, right? So the fact that you have the target site duplications tells you straight up that's a viral insertion. Okay, so now let's get into this more directly here. ERVs are functional genetic elements. They regulate embryonic development, build immune protection in embryos, and even trigger anti-cancer viral mimicry through P53. Their resemblance to retroviruses is necessary for function. Like an FBI agent infiltrating the mob must look the part. Here's the thing. In order to do these functions, the sequences need to be preserved. They need to be under purifying selection to maintain the similarity with, for example, the viruses that they are imitating, right? It's perfectly reasonable to say, oh, the ERV insertion is functional in that it looks like the group of viruses it came from, and then we use that as an antivirus thing, right? You transcribe it to mRNA and it interferes, you transcribe it to a non-coding RNA and it interferes with the viral RNA. That is a perfectly reasonable hypothesis. But in order to do that function, the virus in your genome, the sequence in your genome, would have to maintain a certain level of sequence similarity with the target virus. That means purifying selection must be operating, and we directly document that purifying selection is not operating on these sequences. We can actually directly document that ERV sequences evolve, which is to say they accumulate changes faster than more tightly constrained parts of the genome that are actually under purifying selection, right? So the fact that they're not experiencing purifying selection means the vast majority of ERV sequences aren't doing any of the proposed functions like the ones listed here, because all of these functions, right, regulating this and mimicking that, they require sequence specificity to do it, which means if that function is being maintained, you need to have purifying selection. They don't have purifying selection. They're unconstrained. Less than 10% of the human genome is under purifying selection. I think it's like 8% or 5%, something like that. There have been a couple studies on it, and it's in the mid to high single digits. And ERVs are not in those, say 5 to 8%, right? With a couple of exceptions where we've co-opted it to do a specific thing. And those certainly exist, but the number that we've documented is literally in the single digits out of 200,000 ERV sequences, okay? So endogenous retroviruses are not designed elements, functional elements in the genome. They are the remnants of viruses. They are breaking down because they are non-functional. They don't experience purifying selection, so they can't do most of the functions that are listed here. They can't do any of the functions that are listed here. And the ones that do have functions are preserved via purifying selection. Now let's go to pseudogenes, which is largely going to be the same. And yes, thank you, folks. I appreciate your contributions. Thank you. Everyone fact-checking me is great. 8.2%. I think that's for purifying selection in the human genome is 8.2%. I think that's right. And it could also be the amount of the genome that is ERVs, which I think is about 8%. So yeah, it could be either number. Clarify if you all want whether the 8.2% and 8% here from Larry Moran's book, 8%. I believe that was also in the book that was about 8% purifying selection, but it could also be about 8% ERVs. So if you're checking me on the purifying selection, please say that in the chat so I can just be on the same page. But I think you're all right. I think it's 8%. That sounds right to me. So now let's look at number 6, pseudogenes. Shared pseudogenes are broken genes inherited from common ancestors. And again, like ERVs, more broadly, the pattern of similarity in pseudogenes is very strong evidence for common ancestry, right? You have some lineages that have a functional gene. You have other lineages that have a broken gene, a pseudogene, at that same place in the genome. And the sequence similarity gives you the expected pattern. Yes. So many pseudogenes are functional. That's a statement. You need evidence for that. They act as molecular decoys, regulate protein coding counterparts, and control gene expression networks. That is being very generous because some of these pseudogenes, many of them aren't transcribed, or at least aren't transcribed at a high enough level to matter. And I've got a long video on that from last year dealing with like transcription levels in the genome. But we're not going to go into all the details here. But when they say they act as like molecular decoys or regulate protein coding counterparts, what we've shown is that you can have the mRNA it's not mRNA because it's not protein coding, but the RNA from pseudogene interfere with or interact with the mRNA from a homologous protein coding gene. Whether that is regulatory or not is something you have to evaluate on a case-by-case basis, looking at things like the expression level and the level of purifying selection operating on the pseudogene. And here's the thing, like herbs, most pseudogenes do not experience purifying selection, which means they're not being selected to do whatever job it is. It means the interaction is just happenstance. It's not functional, it's just a biochemical interaction. And this gets into the next line here, because I know you're all waiting for ENCODE. A bunch of people predicted it. The ENCODE project showed that at least 80% of the genome is biochemically active, far from useless junk. Lots and lots of biochemical activity is, in fact, useless junk. It doesn't do anything because biochemistry is messy. It's just probabilistic interactions among molecules in an aqueous environment. It's messy. Those molecules have been selected to do the interactions that are functional more frequently than the spurious interactions, but they still do the other interactions. So this ENCODE thing is silly. There's the big difference between biochemical activity and evolutionary, function. But also citing the 80% ENCODE number ignores, as I've said many times over the years, that ENCODE actually walked this number back, right, in a subsequent paper. Donnie is citing the 2012 paper here while ignoring the 2014 paper where the ENCODE team specifically laid out the conditions where you would evaluate biochemical activity as spurious and non-functional. And then they showed in their own data how most of the activity they documented met those conditions in that 2014 paper, okay? So it's at this point, every creationist who does this for real, whether it's, AIG or CMI or randos like Donnie on YouTube, everyone knows that the 2014 paper exists at this point. And if you're going to cite the 2012 paper and ignore the 2014 paper, you're just lying about whatever it is you're talking about, which in this case is pseudogenes. So let's get to number 7, because that's this topic again, junk DNA. Non-coding DNA is evolutionary leftovers. First big thing right here. Do you all see the conflation? The first big thing, and I'm comfortable at this point calling this a lie right here. Non-coding DNA, right? The heading is junk DNA, and he starts it with non-coding DNA. Those two phrases are not the same thing, and they've never been the same thing, because we documented functional non-coding parts of the genome prior to the term junk DNA appearing in the technical literature, right? Everyone knows this at this point. Promoters and transfer RNAs are my two go-to examples. Transfer RNAs and promoters, we know they're not protein coding. We know they're functional. They were documented at least a decade. I think it was more than a decade prior to, I forget when some of the experiments are with tRNAs. I forget the exact years. And I think promoters were early to mid-60s. So all of those are well before the term junk DNA appeared in the literature, right? So this is just right off the bat, the framing here is dishonest. And Donnie, you should be ashamed. And one, because I know you, Donnie, know the distinction here, but also because, again, remember everybody, this document was put out for his audience to say, here's a quick reference guide to use when you are arguing with evolutionists. Here are the responses to their arguments. If he's going to put this out there, tell his audience to go out there and say, non-coding, we know non-coding DNA has function, therefore junk DNA is wrong, they're going to get smacked down immediately. They're going to get laughed out of the room. Donnie, what are you doing for your audience here? Have some respect for your audience. Don't give them nonsense like this. This is embarrassing. Anybody who uses this in a conversation with, an evolutionist who knows anything about this topic is immediately going to get smacked down if they use this argument here in response to, trying to refute the concept of junk DNA. Okay, so let's continue. Now that we've got the first 2 words out of the way, let's go down here to the creation response. Non-coding DNA is teeming with functions. Objection, assertion, no evidence. You have to provide evidence for that. Don't give me that. From regulatory RNAs, chromatin structure. If this activity were simply noise, as put forth by many defenders, natural selection would have eliminated wasteful transcription since it consumes energy and ATP. That is 100% wrong. There was a paper on this directly on this question from 2015 by Michael Lynch. It was called the bioenergetic cost of a gene, I think is what it was called. And they showed directly that spurious transcription mostly occurs below the selection threshold. The amount of energy that you waste on spurious transcription is too little to be selectable. And actually, that the amount of energy it would take to regulate it perfectly, to have 0 spurious transcription, that energetic cost is higher than the cost of the spurious transcription. Again, this was directly documented in a 2015 paper where they showed that spurious transcription is below the selection threshold in terms of its energetic cost. They also showed that spurious translation is mostly not, which is why junk RNA is very, very common, but junk polypeptides are quite rare because you actually can select against spurious transcription in most cases. Now, I love that some of you in chat knew this was coming without having read this article. I know Andrew got it. I know I saw Andrew say this earlier. Andrew, nice job. And I saw a couple other people say this too. So really nice job that you all know these beats. And that illustrates my point exactly. Illustrates my point exactly. Because, if people in the chat of some random video on YouTube of, let's be honest, kind of a rinky-dink little channel here. This is not like a big operation that I'm doing here. If you all hanging out in my chat can not only refute these arguments, but predict them before you see them, and you're throwing the refutations out before you even see the arguments, what is a random non-expert creationist going to run headlong into when they try to use these arguments? How is that going to go for that person? Like, as a, someone who does this, I don't know, semi-professionally, Donnie, right? You should be aware of that 2015 Lynch paper and not just throw your audience into it head first, right? Because that's what you're doing. You're setting them up to get smacked by that paper. And they're not going to have a response to it. I don't know if Donnie has a response to it. To my knowledge, I've never heard him respond to it, but he's putting it out. He's putting this argument out there as though that paper doesn't exist, which is irresponsible to his audience. It's irresponsible and disrespectful to the people he is claiming to help with this document. And I've said this before, and I'm going to keep saying this. Nobody has less respect for their audience than professional creationists. Professional creationists treat their audience like idiots. And this is a really good example of that. Let us continue. Let's talk about vestigial organs. Vestigial structures, so leftover evolutionary baggage. Again, we got this amateur hour language here, but it shows that you have lost evolutionary functions over time, right? A thing had a function and now it doesn't have a function. It's vestigial. That's what that word means. Creation response, once evolutionists listed over 100 vestigial organs. Today, virtually all have known functions. Okay? That's not what vestigial means. Vestigial doesn't mean it doesn't have a function. It means it has lost the ancestral function, right? The appendix plays a key role in immunity. I don't know about key role because you can get along pretty well without your appendix in terms of immunity, but it does harbor bacteria, right? And that can be helpful in terms of telling your body what's okay versus not. But the appendix in other organisms is a digestive cavity. In humans, it is not. It has lost that function. It is vestigial, right? And in fact, it has to be a lot bigger if it's going to do that function, right? Well, pelvic bones anchor reproductive organs. Is that what pelvic bones do ancestrally? Is that what your hips do ancestrally? Or are they involved in, I don't know, walking? Okay. I see someone says audio is breaking. If that's the case for anyone else, let me know. I can try to futz with things. Let me mute and unmute and see if that happens. Who knows? So I don't think I need to spend more time on vestigial organs. Like, it's an example of structural homology, right? That's what it is. Whether it's functional or not, has the same function or not, it's an example of structural and developmental homology, which is strong evidence in favor of evolution. All right, most people are saying audio is fine. Cool. All right, now we get to DNA similarity, which we've already talked about this a bit in other contexts, but we'll do it again. Oh, this is the human-chimp one, of course. So humans and chimps share 98 to 99% of the DNA, proving common ancestry. Once again, it's not about proving anything, it's evidence, right? The pattern of similarity, humans versus chimps versus gorillas versus orangutan, right? The pattern of similarity, the relative degrees of similarity, is the evidence for common ancestry of all of these organisms. So it's not about proving common ancestry just between humans and chimps. It's the relative pattern shows the pattern of evolutionary relatedness. So SFT writes, that number is cherry-picked. When gap size differences and structural variations are included, the figure drops to 85% similarity. I think that's a 2025 paper, but I think that's supposed to be a 2025 reference, if it's the one I'm thinking, but whatever. More importantly, similarity is agnostic. There it is again, folks. Common design explains it just as well as common descent. No, it doesn't. No, it doesn't. Because it's the pattern that matters. It's the pattern that matters. And the creation, right, followed by evolutionary processes, is incapable of getting the nested hierarchical pattern that we see today. You can get that pattern through creation and then supernatural intervention, right? Supernatural manipulation of natural processes, but that is an untestable, unfalsifiable idea. You cannot have separate creation at whatever point in the past and then get the pattern of similarity we see. And it doesn't matter what the number is, 98, 85, you're making different comparisons, right? It's not an apples to apples comparison. Doesn't matter what that number is. As long as you're consistent in the comparison, you get the same pattern. Now, when you use the lower number, if you apply that technique consistently across different groups of organisms and within different groups of organisms, you also see, for example, a similar amount of divergence within single species. For example, gorillas. If you're going to say that the lower number is a challenge for common ancestry of humans and chimps, then you also have to say that not all gorillas share a common ancestor, which is, nobody thinks that, right? No creationist says that gorillas don't all share a common ancestor. So Donnie, I think, recognizing that problem, has the fallback position here of it's agnostic, right? This is plan B. Oh, well, you know, creation can explain it too. One, no, it can't. And two, it is a specific prediction of evolution where it is not a specific prediction of creation. There's no reason you need that pattern in a creation model, but you need that pattern in an evolution model. And that's exactly what we find. Right. Then we get into this thing about the Y chromosome, which this has been explained to Donnie so many times, I swear. This is where Gutsa Gibbon has explained this to him to his face, where the human and Y chromosomes are less than 30% similar due to structural differences. Basically, you have deletions in non-protein coding, non-constrained regions. That's not the same thing, because deletions are singular evolutionary events. Such massive differences are impossible to reconcile within evolutionary timeframes. So there's two things here. One, we can explain this pattern through sexual selection operating on the Y chromosome. This has to do with differences in mating pattern and population structure between chimps and humans. Again, this has been explained by Gibbon to Donnie, to his face. He knows the response to this, and it's irresponsible for him to make the argument without the response for his audience to then turn around and make, because they're going to get smacked down. But the other thing is that this very last line here is alluding to the waiting time problem. So if you had waiting time problem on your bingo card, you can check that off right here. This is a waiting time problem argument. He's saying the number of changes that are required is too great to occur within the 6,000 years, or 6 million to 8 million years since humans and chimps diverged. Yeah, I see people periodically, it's like one or two people here and there, but then every time it comes up, a bunch of people are like, no, it sounds fine. So I don't know if it's person specific or what. I apologize. I don't know why that's happening, but Pragmatic Crystal's about the third person to say it, but then everybody else is saying it's okay each time it comes up. So I don't know. Sorry, everybody. Okay, as I was saying, this is a waiting time problem argument right here, but the thing is, it's not, because if you have a 10,000 nucleotide deletion, that's not 10,000 changes that have to occur. That's one thing that happened. It's 10,000 bases being lost in a single evolutionary event. That's not a waiting time problem. That's not an issue of too many mutations happening too fast, right? That's not hard to explain because, again, major things like deletions or duplications, those are singular evolutionary events. So when you have a 10,000 or 100,000, whatever size it is, nucleotide deletion, that happened all at once in one of the lineages and not the other. Boom, instant 10,000 nucleotide difference, one event. That doesn't take any longer than a single point mutation. But creationists like to pretend that each one has to be its own thing. And that's just silly. It ignores how evolution actually happens. So let's keep going here. We're getting near the end already, folks. Mutations and natural selection. Folks, this is the genetic entropy one. This is the genetic entropy one. And do I have to say anything else? I can just say genetic entropy, Hancock and Stern Cardinal, 2024, done. Okay, beneficial mutations plus natural selection drive evolutionary progress. I don't like the word progress there because evolution is not a progress-driven process, right? I would say drive adaptation, right? Mutations and selection drive adaptation, I would say. But I don't know if progress is the right word. In fact, I'm going to say that progress is the wrong word because it's not a progress-driven process. But let's get to the response. Mutations overwhelmingly break things. Rust on a car, drink. That's a classic. Typos in encyclopedia. We inherit about 100 new mutations per person, per generation. Slightly harmful. Selection cannot remove them all. This is like word for word John Sanford, Genetic Entropy and the Mystery of the Genome. And actually, I'm just going to go down to the bottom real quick and check the sources because I want to see if he actually cited it at all here. Let's see. Radiometric dating. Okay, he did cite genetic entropy. Yep, there it is. That's exactly right. Good. Okay, so he's not plagiarizing. He's just being lazy and citing an out-of-date resource. Could be worse. Could be plagiarizing. So this leads to genetic degeneration, not innovation. He's saying genetic entropy without saying the word genetic entropy. And then even beneficial mutations are usually reductive, e.g. sickle cell disease protects against malaria. It's disease is the correct word, not anemia, but that's the old word, but whatever. It's caused by a broken hemoglobin protein. So sickle cell disease doesn't protect against malaria. I mean, at least get the basic facts right here. The sickle cell allele confers resistance to malaria. If you have two of the alleles, if you're homozygous for it, you have sickle cell disease, but it's the allele that protects against malaria, not the disease. Just be clear on that. It's an example of a dynamic called the heterozygote advantage, where the most fit genotype is to be heterozygous, to have one copy of the sickle cell allele and one copy of the wild type allele. So you don't have the sickle cell symptoms, but you do have the malaria resistance, right? Another way to think about this is that sickle cell is a recessive trait, malaria resistance is a dominant trait. They are both associated with the same allele, right? So that's what's going on there. It's not that the disease protects against, it's not that sickle cell disease protects against malaria. That's not how it works, just to be clear. You don't climb a mountain by falling more times than you step upward. Again, this is a genetic entropy argument, and I will refer Donnie and every other creationist to Hancock and Stern Cardinal 2024, which to date, in September of 2025, literally 0 creationists have attempted to respond to. If that paper is wrong, all you have to do is show that the math is wrong. There's math. Just show that it's wrong, and you will refute that paper. Not one single creationist to date has publicly refuted that paper. I don't even know if they talk about it amongst themselves. Maybe. I have no idea. But publicly, they pretend it doesn't exist. It's a direct refutation of genetic entropy. And that's all you need to know for that one. Just throw it out there. Now we have molecular clocks. Evolutionary claim. Mutation rates show humans originated hundreds of thousands of years ago. It's actually substitution rates, not mutation rates. Mutation rates, that's the rate at which changes occur in your genome. What's relevant when we are going to calculate the time to most recent common ancestor, which is what we're doing with molecular clocks, what's relevant there is the substitution rate. That's the rate at which mutations achieve fixation in the genome. Or another way to say that, a less technical way to say that, is to say the rate at which mutations accumulate in genomes over time, right? So Donnie goes on to say, this one's just amateur hour. This is possibly the most amateur hour. Evolution relies on assumed slow rates. No, it doesn't. 100% no, it doesn't. Observed pedigree-based rates are much faster. mtDNA mutation rates traced to a single mother thousands of years ago, biblical Eve. Y chromosome about 4,500 years ago, biblical Noah. That is 100% completely wrong. Every sentence in there is completely wrong. So 1, evolution relies on assumed slow rates of fixation. No, that's wrong because we've directly observed the evolutionary rates. All you have to do is look at pedigrees that go back to a fixed point in time that we know of. Okay? So, for example, just to give you a couple of examples, there's a Y chromosome pedigree paper that looks at an extended Icelandic family that goes back, I forget the number of generations, it's like 5 or 6 generations. And when you use the rate of mutation accumulation in that paper, you get a time to most recent common ancestor for the Y chromosome that's going to be in the evolutionary time frame. We're talking hundreds of thousands of years. Similarly, I think there's a similar study of I think it was from a Japanese population, a Japanese family. It was a similar thing going back to the 1800s. There's the mitochondrial study of the Tristan da Cunha founding population from the early 1800s. There's the one of my favorites is, the name of the paper is great. It's King et al. And I forget the year, but it's King et al. And it was a study of the mitochondria of King Richard III of England. I think it was Richard III. And basically what they did is they identified 2 living descendants of Richard III through his maternal lineage, right? So the same mitochondrial DNA lineage. And the creationist rate, if you use Jeanson's rate and you track that lineage through time, given the rate of mutations that Jeanson proposes, this is Dr. Nathaniel Jeanson from Answers in Genesis, who Standing for Truth is referencing here. In fact, let me just go down and look. This is number 11. Let's see if he references Jeanson. Here we go. No, he doesn't reference Jeanson at all. He's cribbing from Jeanson. He should reference Jeanson there. But anyway, if you use Jeanson's mutation rate, you should get like, I forget, it was like 10 or 12 or 16 mutations in that mitochondrial lineage. And according to the evolutionary rate, the assumed evolutionary rate, you would predict either 0 or 1. And in the 2 descendants they identified, one of them had 0 mutations and the other one had 1. So, and then another thing you can do to show that these evolutionary dates are accurate is look at migration events where we know historically when the migration occurred. So my favorite example of this is the Canary Islands. So we know that the Canary Islands were colonized from North Africa. We know when that happened. So we have the indigenous Canary Islands population and we have the North African population. Those are the sister groups. We can look at their mitochondrial divergence and calculate that going back to their divergence time when the islands were settled. And Jeanson's numbers at best predict over 5 times the number of mutations we actually see, right? They're just way too fast. They're wrong. So this first line, right, relies on assumed slow rates. No, it relies on directly observed rates of accumulation. Emphasis on directly observed. Pedigree-based rates are not much faster. You can cherry pick one generation pedigrees, single generation pedigrees, and you get a faster rate. But those studies, like the famous Ding paper that Nathaniel Jeanson uses, Ding 2015, I want to say, those authors explicitly did not weed out or account for somatic mutations, mutations that are not in the germline and therefore will never get passed on. So you end up with an inflated generation to generation mutation rate, and then you have to extrapolate that erroneously fast rate backwards in time. It was David Neff. I did a show on that with him years ago on this, where he emailed the authors, Ding, and said, hey, did you account for somatic mutations? And they were like, no. In another example of Jeanson's awful methodology that's being cited here, specifically for Y chromosomes, Jeanson does like a CSI zoom and enhance on a figure of a paper to calculate the rates, to kind of extract the number of mutations. The people that did that study didn't actually correct for sequencing errors. So the mutations that Jeanson were documenting was indistinguishable from the equipment error in the techniques that they use, because they weren't interested in the actual sequence. So they just didn't do the quality control because they didn't have to. It wasn't relevant to the study that they were doing. So Jeanson was literally just sweeping up instrumental error and saying that was a faster mutation rate. Yeah, I don't know what to tell you. Like, creationists are just using literal instrumental error here. So that's all that. Dating methods. Next, radiometric dating proves Earth is billions of years old. I'm gonna let the proves go on this one. I'm gonna agree with that on this one, because the Oklo natural nuclear reactors prove that radiometric, or I should say radioactive decay, fission, neutron capture, all these processes have operated the same way they do now for at least 1.8 billion years ago. So yes, this one, I'm gonna let proves, I'm gonna okay that one for this one here. Dating methods are riddled with contradictions. Newly formed volcanic rocks date as millions of years old. That's because you're using the wrong techniques. You can't use a technique on brand new rock. Okay, you can't do that. That's saying, okay, I've got a grain of sand, and I'm going to take it to a weigh station on the highway, right? And I'm going to use the truck scale to try to weigh my little bit of sand. It's not going to work, right? Or they go the other way with carbon-14, which you have here, C14 in ancient samples. Okay, carbon-14 will always get you, when you do those techniques, you will always get some background number, because the instruments will always return some background number. That's how it works. One of the most famous studies on this, the one in diamonds, it's literally a calibration test for the instruments. And creationists are running with that, saying, oh, look, there's C14 in the diamonds. It shouldn't be there. It's literally a calibration test where they're zeroing out the instrumentation, saying this is the background that you're always going to get no matter what. So you have to account for that when you do the techniques, right? So you can take something that's 10 million years old that has no carbon-14 in it, or no detectable carbon-14 in it, and measure the carbon-14. You can do the test, and you're going to get like 100,000 years, because that's just the bare minimum you're going to get because of how those tests work. And again, I want to emphasize this so everyone's clear on this. The study specifically with diamonds was to calibrate the instruments. That's what creationists are citing here. Okay. Now, the other side of this, and I love it because chat has beaten me to it. Thank you. Darren Simmons has got me here. Argon was used on rocks from Mount Vesuvius from 79, Common Era. And it's dead on to the year. Yes. So you don't have to go back too far, right? You do it on something that's 30 years old or 40 years old, it's not going to work. But you go back just a couple of thousand years and you can get dates that are bang on from history, what we know it is, okay? So creationists, you can keep trying to dispute radiometric dating. No one's going to take you seriously until you can come up with examples that are legit. Another one, helium retention and zircons. This has been explained a million times. Friend of the channel, Age of Rocks. Check out the channel Age of Rocks. He does great work on all this stuff. He's actually like hands-on shown how this stuff works. It's super cool. He does really good work explaining this. Check it out. So this is just silly. And this is not my field, but I can give you enough to get you started. All right, we're almost done. Taxonomy. Classification of organisms, kingdom, phylum, family, whatever, reflects evolutionary history. It should, but the Linnaean system doesn't. Taxonomy is a human system of organization. Yes, and we're back to vehicles. I'm not going to bother with this. Who cares, right? Who cares? All right, genetic diversity. The amount of DNA variation requires long evolutionary time. This assumes all diversity arose by mutations. Here we are in created heterozygosity land, everybody. Creationists instead argue for created heterozygosity, built-in DNA diversity from the start. Bottlenecks reshaped, but did not erase this diversity. Okay, I've actually personally done the math on this. I have personally done the math on this to show that for highly diverse regions of the human genome, like, for example, the ABO blood group gene, you don't have enough time, even if you start with 4 distinct alleles. You don't have enough time to get all of the different variations we see. Now, there are 3 main alleles, right? A, B, and O, but within those, there's over 1,000 distinct variants. So you can start with 4 alleles, and you need to have recombination to get all those variants. And I've actually shown that the rate of recombination is thousands of times too slow. Thousands of times too slow. Not 50% too slow, not 10%. It's thousands of times too slow. So in order for this hypothesis to work, this mechanism of created heterozygosity, you either need a completely unobserved bananas mechanism of having more diversity at the starting point, like polyploidy, or some creationists have proposed germline diversity, where all the different germ cells, the sperm and egg, have different alleles in them. Or you could either go with one of those ad hoc explanations, or you need to propose recombination rates that were thousands of times faster in the past than we observe them to be today. That's how you make created heterozygosity work. You can go back through my channel. I have a video specifically on this where I do the math on screen. Okay, so the math doesn't work. Creationists have never even attempted to explain that. They just hand wave it. That's all there is to say about that. And that's it, folks. Now we're up to conclusion. Every best evidence for evolution collapses under scrutiny or is equally explained by common design. That's it. Nothing here is doing anything except setting up Standing for Truth's audience for failure. And once again, Donnie, I just want to say, like, have some respect for your audience, because this is doing them a disservice. This is doing them a disservice. Yeah, that's a great question. What about the heat problem? We don't have an answer for that one. I don't know if you've noticed, but they've gone back to hydroplate because CPT, they can't explain the heat problem with catastrophic plate tectonics. So yeah, they're not going to bring that one up in the catch-all, here's how you answer all the questions document. Now, before we go, I have a couple things I just want to point out. From Donald, Dan, do you have a video on your genetic entropy paper? I do, and then Zach has a more detailed one on his channel. So if you go back to last year, like last spring, last summer, you're going to find those videos. Check those out. And then Crazy Cat gifted 5 memberships, and in all the scrolling, I missed who got the memberships. But Crazy Cat, thank you. That was extremely kind of you, and I appreciate that. So, folks, that is where we get to leave it for tonight. Like I said, it had been a while since we, dunked on Standing for Truth, because I admit it's a little bit lazy. It's always, it's low-hanging fruit, but it's useful to every now and then just see what, like, the people a step down from, like, Answers in Genesis are doing, or maybe 2 steps down, because, ICR has definitely a step down, or Genesis Apologetics. But, what are, like, the affiliated people doing, just like on YouTube, when they're talking about this? Well, this is the kind of stuff they're putting out. They're putting out these documents saying, audience, creationist, here are the answers for you. This is like the dollar store version of the Answers in Genesis answers books that I've been slowly working my way through. Except it's much, much worse, right? It's attempting to be, like Donnie says, it's attempting to be a cheat sheet. But what it is a guide to how to faceplant in these arguments. Because if you are having this conversation and you encounter someone that knows anything about this stuff, even just a little bit, they're going to completely steamroll through the arguments in this document. Because these are just the shallowest, most basic amateur level arguments with no sophistication. And like I've said a couple times, speaking directly to Donnie, like, what are you doing? Have some respect for your audience. Have the decency to give them resources that aren't going to get them just completely rolled over if they try to use this stuff in a debate situation, right? If you go on like any, open mic kind of thing and bring this stuff up, somebody in that room is going to smack you down hard if you use any of these arguments, because these arguments have not been new in decades. There's nothing here that is creative or sophisticated or accurate. So it's bad. It's bad, folks. But this is what creationists are putting out there, because remember, they can get away with this because 2 reasons. One, the point is not to be persuasive. The point is to reassure your flock, right? This is the AIG defensive crouch strategy. It's all about keeping people in the club rather than convincing the people outside the club. The second reason they can get away with this is because it's not actually about the science. It doesn't matter if they're wrong. It doesn't matter if the arguments are somewhere along the range from unpersuasive to you will get laughed out of the room. Doesn't matter, because the science is not the point. The point is the culture war stuff. Creationism, whether it's young earth creationism, intelligent design, which is, creationism literally with a different word at the front of it. It's all about the culture war. It's all about imposing a Christian nationalist, theocratic, reactionary conservative order on society. The science doesn't matter. The science is just getting your foot in the door for some of the people. The science doesn't actually matter. And that's why they can afford to be completely shameless and laughably wrong about the science. So keep that in mind. Keep in mind what we're doing here. I'm trying to equip people to be able to respond to the scientific arguments, but never get into a mindset where you think that is the entire ballgame or that is the point of all of this, because it's not. This is just one front in the broader culture conflict right now between a liberal, pluralistic, democratic society and like open Christian nationalist theocracy, right? This is just one little piece of that ongoing conflict where I'm trying to equip you all to push back. And I hope I'm doing a better job than Donnie is doing with his silly document that we just went through. So that's where we're going to end it for tonight, folks. Thank you all for hanging out with me as we went through this. My hope is when you find yourself in these types of conversations, you can take what we've talked about and use it to your advantage. So thank you, everybody. Stay healthy. And anytime you encounter this stuff, don't get fooled.